Thank you guys for joining today. Bit of like housekeeping first. Today we're going to have a nice session about really how Harness can enable you to really experiment at AI speed. We're going to show you a little bit of like how we see the industry, how we see data warehouse native, and then we're also going to throw you a bit of a demo of how it actually looks in reality. If you have questions throughout today's session, please just throw them in the chat, and we're happy to ask them for the entire session today. All right, so bit of quick intros for who are we today, who are you listening today. So I'm joined here today by Audrey Lowe, who's one of our lead product managers for Data Warehouse Native. Data Warehouse Native is one of her brainchilds here, and she like nursed this entire product to really get into a really comfortable space to solve a lot of like our customer problems. And I'm Alexander Bock, and I'm the advisory director for Harness, specifically for feature management and experimentation. I've been an industry practitioner for the last 10 years at led large-scale experimentation practices at firms like, for example, JP Morgan Chase. All right, so what we're going to do first. First, I'm going to give you a bit of an overview. Then I'm going to go over, switch over for Audrey to give us a bit of a see how Data Warehouse Native can solve the problems, and then followed by a quick Q&A session at the end of today's session. All right, so let's jump straight into this whole thing. All right, so these days, a lot of product teams are promised productivity for the rise of AI. You know, they are promised the holy grail of AI coding tools that they are able to like do more faster code generation, faster go-to-market, and just general better quality and a faster speed at times. So, and in many ways, that revolution has come, and writing code has never been easier. You know, shipping things to the customers has never been made easier from a just purely coding volume point of view. However, instead of getting productivity, a lot of product teams are now faced with increased complexity, right? Because now we have suddenly more code to test, which basically means more features to test, more code to secure, more code to deploy. So in many ways, while writing code and creating new features and creating new customer journeys have become much, much easier, shipping those set features has become incredibly difficult to the extent that some organizations really struggle now with this. And this is where we see a massive problem within the industry, right? So lots of product teams and developers currently spend around 30 to 40% of their time actually only planning and coding and actually building these set features, and then spending the other 60 to 70% of the time to actually just to test them, secure them, deploy them, and optimize set features to make sure that they're not breaking and to ensure that they're actually doing well for the actual customers. But there's a problem with that, right? So if your testing features are, if your testing infrastructure is not working reliably and is unoptimized, if your security teams are siloed and working not in the right way, and your deployment pipelines and the release pipelines are very brittle and you have to babysit them all the time, and your optimization strategies are not really put in place, you can't really benefit from all these AI tools out there to like help you ship software faster, more reliable, and at scale, right? So it's not then only a problem of like, how can you make this nice and how can you move fast? It becomes increasingly complex to actually safeguard your releases in a good, reliable manner. So this is what we see in the industry, right? AI is great, AI is cool, but it's actually making all these problems worse, right? If you don't have, if your testing stuff is not manual, if your security is siloed and everything, then all these things are just 4x, 10x, depending on how much code and how much items you want to push for your deployment and release pipelines. And so you really end up in a situation where, yes, maybe you have had efficiency gains, but now the downstream impact of those things is actually, you're not seeing this return of investment. You're not seeing your AI initiatives like really giving you the return of investments that you were hoping to achieve within your organization. And this is basically what we want to solve for at Harness. But to like give you a bit of a mental model of how we see risks and how we see why things in AI is making things worse at times. The fundamental model of how we operate as a company is we see that change is really the atomic unit of risk, right? Every outage starts with a change. Every security breach starts with a change. Every incident starts with a change, right? So in our modern world, from a product point of view and product development point of view, so it's not really the question anymore, can you just write code fast and like, can you just ship as fast as possible? It's about how you can ship your code and your new features to production in really a safe, secure, and at scale manner, right? And that just goes beyond just feature flagging, experimentation. It goes to your API scanners, your security scanners, your deployment pipelines. And this is what our truly mission statement here is Harness, right? We want to enable the world's 37 million software developers and the countless AI agents that now generate code to help them deliver quickly and reliably, efficiently, and securely, right? This is why we built Harness, the Harnesses platform in 2017. And over the last nearly 10 years, we expanded in all kinds of different areas from DevOps automation, testing resilience, security compliance, and cost optimization, spanning nearly 17 different modules, right? From DevOps, reliability, security, and efficiency. Today, we're going to focus mainly on feature management experimentation, specifically warehouse native, as the last step in the software delivery cycle, right? Because if you build a lot of things, you need a way to estimate, does it actually work? Does it generate some sort of return on investment of all the things that I've built? So say you have a good deployment pipeline, a good release pipeline, good security scanners and everything, and you can release your features from a pure technical point of view in a safe and reliable way. That's great. But the main question always then pops up with business leaders, product teams, UX folks, the finance folks within the organizations is, okay, we just spent maybe 3 months, 4 months, 6 months building this feature, but does this feature actually help our customers and generate revenue, right? And in my 10 years of building large-scale experimentation programs and running hundreds of tests, I basically figured out that around 20% of all new features actually have a negative impact on your customers, right? 60% do nothing, and only 20% actually drive a positive outcome, right? So if you put that in perspective, like if you working in this modus operandi where you're constantly building and releasing features and you're not actually measuring what the outcome of is, nearly 80% of all your things either harm your customers or do nothing at all. That basically means you're accumulating tech debt, you're accumulating all kinds of features that you don't need to maintain, or you actually doesn't help with the value proposition of your company. So the easy answer to understand what works and what doesn't work, you need to run an experiment. You have and what is an experiment? Just to set the baseline again, you have a set of group of users, you bucket them into an existing feature and a new feature, you measure the data, what they're doing over time, and then you measure the impact on every metric, every feature, and every rollout, right? To understand what worked and what doesn't work. So for many organizations, experimentation is not new at all, right? Experimentation is a concept that's been around since the early days through the agricultural revolution. Famously, Guinness used experimentation as a methodology to understand and to brew the best pint of Guinness. But in the modern tech world, experimentation really got hold in the last probably 10, 12 years, like from big companies like Microsoft, Netflix, and Amazon. And within that scene, a whole set of vendors came to the market that basically serve companies' experimentation needs. And the first type of version of experimentation that was sold by many vendors was effectively cloud experimentation, the OG kid on the block. And cloud experimentation is basically nothing else than you have some sort of SDK, you have some sort of service that you deploy in your applications and your webs, in your websites. It decides whether or not to render something to something, and then measures the analytical events, so the front-end events, to see how people are moving through the application, what the conversion rates are, and so on, and then measures what works and what doesn't work, right? This is one of the offerings that we have here at Harness as well, which we call, obviously, cloud experimentation. The problem with cloud experimentation, it does only one particular job. It looks at front events. So in the last couple of years, there's a couple of other new vendors and other new methodologies coming in the industry called And they all call this warehouse native. So what we can now call the new kid on the block. And basically, warehouse native basically says, I'm just the attribution engine. I'm just basically a experimentation analysis engine to see what works and what doesn't work. I don't care who and how that experiment got actually served to my customers. I'm actually just doing the analysis itself, which is great for companies that not only want to look at front events but also back end events. But more to that later when Audrey gives us a bit more of a demo. So let's look a bit of the reasons again why cloud experimentation struggles and why you might want to consider data warehouse native as a solution, right? So as I said before, cloud experimentation relies on events from your app and app sites to drive the analysis, right? And that in many cases, that solves probably 80 to 90% of all the cases and from an analysis point of view that you will have in your front end. However, for like some, for example, companies like big banks or insurance companies or companies that have like NPS scores, that is not enough to like get the full picture of how my variation and how my experiment has actually performed, right? Because if your primary metric is not an event, you might not be able to do the analysis in cloud experimentation. You need another tool. But because most of these experimentation tools that are out there these days are purely cloud experimentation, you ended up where you have where you have lots of different tooling sprawl, right? So say you want to run a company-wide experimentation program across your social media, your web pages, your apps, and your content strategy. You might have now different vendors that all have different flavors of cloud experimentation for different like instances and different areas within your product. Right. So now suddenly you have, so in this instances, you have vendor 1 for social media, vendor 2 for web pages, and vendor 2 for your apps, and vendor 3 for content. So suddenly you have 3 different assignment sources to decide what should be rendered to your customers at what given point of time. And you might have 4 different sources of truth from an analysis point of view of like, how has this now performed throughout this entire journey. So you ended up with a very disjointed analysis tool stack where a data scientist, a product manager has to go to every single tool to see how has this experiment performed through the entire journey that I have created to measure the impact of the initiative I'm trying to test. And this is why warehouse native becomes really, really powerful, right? Because if you can't consolidate the assignment tools or the tools that allows you to render certain things to different customers, but you want to have a single source of truth from an analysis point of view, this is where warehouse native comes in, because warehouse native now basically becomes the control plane, the single source of truth that tries to consolidate all the different analysis streams, analysis metrics, in a single instance, so that the data scientists, the product managers can use this to then report of what has worked and what hasn't worked. You should see now it's also pop up a poll on your screen where we wanted to ask you guys is like, what kind of like data warehouse do you guys actually use? Because the warehouse native, as it says in the name, is called data warehouse native. And data warehouse native effectively means it has to run in your warehouse. So we would love to understand what kind of warehouses you're currently running. After that, Paul, I'm going to hand it over to Audrey, who's now going to walk us through some actual use cases, how customers have used this, and give you a bit of a flavor of like how it looks in reality with the Harness Data Warehouse native solution. All right. Over to you, Audrey.
Thank you, Alex, for that great introduction. And hi, everyone, again. My name is Audrey. I'm a product manager at Harness for feature management and experimentation, specifically that last part, focused on experimentation and release monitoring. So good morning, good afternoon, good evening from wherever you're calling in. Before we jump into the product demo, I want to ground this example in a real customer test that we helped the client run. So this customer was a large retail bank that had just rolled out an AI-powered support assistant to handle customer inquiries. So these are things like password resets, transaction questions, fraud alerts, open tickets. And for the purpose of this demo, we'll be using sample data, but this reflects a real test that they ran with an experiment. So this customer felt that the assistant was critical because it directly impacts customer satisfaction, support costs if they can automate responses to these types of inquiries, and operational efficiency. And they wanted to test this with 2 different prompts. They had a general prompt that you could see on the screen. It's very basic. You are a customer support assistant. And then they had a structured prompt that gave it more detailed instructions and response guidelines. They couldn't use traditional cloud experimentation tools because their data had to stay in their warehouse, especially because this is a bank. It has sensitive financial data and PII data that they wanted to keep secure and not send to other tools. They also didn't trust metrics defined from tools outside of their warehouse, where definitions could diverge from their governed models, and which would much rather have it be all in one place. In the previous slide, when Alex talked about, all of these different data tools, bring them into one place, clean them, maintain them, transform them, and have that be your sort of central headquarters for data. So they needed to test this new AI assistant, and they needed to use their warehouse as the source of truth to keep that sensitive data secure and move faster without having to stitch together these multiple tools and send them and duplicate data pipelines. So with that, I'll share my screen and go into the demo. All right, so here we are in Harness FME, where we land in project settings. This is the first step where you will establish your data source connection, and this is your connection to your warehouse. So what this customer did is they created a dedicated service user with the necessary scoped permissions to the specific database and schema that contained the tables that they needed for their experiment. And it's important that this service user needed certain permissions. They needed read access to the assignment tables, which I'll talk about in a bit, read access to their event tables, and write access to a designated results table, which they input down here. And the point I really want to emphasize here when connecting to your warehouse is that the data never leaves. The queries run in the warehouse, and it's with this service user with the scope permissions that it can know which queries it needs to use when running the calculations. And everyone is working off of the same source of truth. Also, because the analysis is running directly in the warehouse, their data team can inspect the specific SQL queries being used and executed if they ever wanted to validate the logic or understand how the attribution is working, or even if they want to replicate the results and rerun the queries or do the same definitions in a different tool. They can do so, and everything is fully transparent. And with that results table, they write to it so that when they run an experiment, we copy those aggregated experiment results. And from that results table, they can audit and validate it. They maintain a historical log of all of the experiments they run with Harness Warehouse Native. They can use that data set to export it or show it in another dashboard or join with other data sets for further analysis. And by doing this all in one place, they eliminated a huge amount of back and forth between their data engineering teams, their product teams, and engineering teams. So after we've established the connection, the first step in running an experiment is setting up your assignment source. So I'm going to pop in here, and I've already created an assignment source. And simply put, an assignment source is the table that tells us who saw what experience and when. So in this case, they have a table that contains their assignment data with a little data preview there. And they were using a Harness feature flag that controls the rollout of these 2 experiences and the targeting for who was assigned which version, the general prompt or the structured prompt. And when you set this up, Harness will require you to tell us 3 fields, which goes back to that who, what, when. In this case, the who is the unit key. In this case, that's a user ID. The when is at what time were they exposed to the AI assistant and shown the structured prompt or the general prompt version. And then the treatment, which is those 2 versions that I just mentioned to keep track of the 2 different groups. Optionally, you can add custom fields. So custom fields are really useful if you want to reuse this assignment source and filter on it later. So how they had structured their assignment source table is that it included all of their experiment exposures, and they had a column identifying what particular experiment it was for. So when we go on and create the experiment later, it will filter by that experiment ID. And also targeting rule, which is part of the feature flag and tells you which population you are experimenting on. So in this way, assignment sources become reusable. It reduced their setup time significantly, and they can use this to run multiple experiments and only maintain one assignment source that's already been created and cleaned and transformed in their warehouse. So after we do the assignment source, we're going to do the same thing, except now for metric sources. And the form will look very similar, where you connect to a table. I have a little data preview there. You also have the option to point to an existing table, or you can even write some lightweight SQL in here. We don't recommend huge transformations with the SQL editor, but this is for things like if you wanted to convert data types or rename or some columns or do some like joins. But here they have a long form events table that contains many different types of events, an event value, and the user and the timestamp. So the metric source, think of it as an event log, and it captures what their users did after engaging with the different versions of the AI assistant. And again, we map the necessary fields. So we need to know what was the event, if there is an event value associated with it so that we can aggregate on it later. Think of things like an event type is a purchase event, and the event value would be the purchase amount in US dollars, for example. Then we need to have the key. So in this case, it's a user ID, and this key needs to be the same key that we referenced in the assignment source so that we can do the joins when running the calculations. And then again, the timestamp and the option to add some custom fields, which could be used for filtering metrics down the line. And even though in this example, we're using one metric source that contains a log of many different types of events, you also have the option to create multiple metric sources depending on where that data originated. So this could be front-end events, back-end services, NPS scores, financial data. As long as it lands in the warehouse and you have the who did what and when, and we can join that to the assignments, we can run an experiment off of it. So after you create the metric source, now it's time to define some metrics. So I've created a few here. For this particular experiment, I'll zone in on resolution rate. So this will be the key metric for the experiment, which is did the AI assistant successfully answer the user's question and have that query closed. And then another metric we created here, I set average response latency as a guardrail metric. Guardrail metric is something that you want to keep in a healthy range and not have it degrade past a certain point. And so here we're keeping an eye on this to make sure that this stays healthy. We don't see any major degradations. You also have here's an example of applying a filter. So here I filtered the event value to be less than 10,000 milliseconds or 10 seconds, and this is to exclude any extreme outliers that maybe aren't representative of what's actually going on and we need to filter out. So when you create these metrics, these then become reusable, where maybe if you want to run a follow-up experiment, testing maybe another iteration of the prompt, you've already defined these metrics and you can reuse them and add them to experiments. All right, so now that we have everything that we need, let's go into the experiment results. So here is the experiment results dashboard. Before I talk about the results, I'll show you how that setup is. So once again, here is where you will add the assignment source. I filtered by those custom fields I mentioned earlier to make sure that for this particular experiment, it's scoped down to the correct user population. You set a time range, you can add a hypothesis, where here we believe that the structured prompt will perform better. And that's what you need to set up the experiment. After that, we've come in here and we've added those metrics. You can view the hypothesis. You can do a health check to make sure that that everything is good and ready to analyze. And here is the metric table. One thing I want to call out here is that what you're seeing in this dashboard is aggregated results. Harness will never see or store any of those individual rows of sensitive user data or event data. So all of these aggregated results are the same thing that's going to be copied to that results table that the customer can then further drill into and join other data to. But this is a key point of Warehouse Native, especially for customers like a bank that values data privacy and security. So starting with our key metric, the support resolution rate had a positive outcome, aligning with our hypothesis that the structured prompt would perform better. We don't see any conclusive changes with the average latency. We see an improvement in the escalation rate. So this is how often are users escalating to a human support engineer. And we're even seeing some positive feedback that, at the end of their interaction, they gave it a thumbs up and were satisfied with the structured prompt responses more so than the general prompt. And so you'll notice that some of these metrics are inconclusive. So follow-up question rate, this is if they've had to ask more questions, and maybe the first initial response wasn't descriptive enough, so they had to ask for more details. We see a trend in the undesired direction, but not enough for us to know conclusively. So these are opportunities to follow and iterate on follow-up experiments. So what did the customer take away from this? Before, running an experiment like this would require stitching multiple tools together, reconciling different metric systems, waiting for teams to set up those data pipelines for them. And it was just a long and slow and hard process to trust. And if someone had a question like, hey, how is this metric defined? Or what filter did you apply to this metric? Or how can I replicate this result? It's not matching what I'm seeing in another dashboard. It was very hard to trace that back and be able to compare apples to oranges. But by moving experimentation directly into their warehouse, they were able to reduce their setup by about a factor of 5. And what used to take days or weeks could now be done very quickly in hours after you've connected to your warehouse. And that's be compounded. This customer went from running about 10 experiments a month to over 50 experiments a month, which fundamentally changed the way that they approached their AI roadmap and enabled them to iterate and innovate at a much faster speed. At the same time, they eliminated the metric drift where they could, like I said earlier, inspect the SQL and make sure that their metric definitions were aligned everywhere and ensure that everyone was on the same page, working off of the same data in one place. And even when results are inconclusive, it didn't slow them down. They then continued to iterate on more prompts, on more tweaks to the AI model, and by being able to move faster, helped them iterate and launch on their next experiment. So this is what it means to truly scale experimentation as part of your AI strategy too. And if you take one thing away from what is the value of Warehouse Native, is that you can run experiments where your data already lives. And that's how this team was able to move faster, trust their metrics, and keep their sensitive data secure. All right. And with that, I'll hand it back to Alex, and we can go into Q&A.
Awesome. Thank you very much, Audrey. That was a really nice overview. All right. I see that we have a couple of questions, which is great. Thank you very much for submitting those. Let's start with the first one. All right. Let me just display this one. Okay. So the first question that we had was, can I use a marketing tool like Optimize for this? All right. Do you want to take this one, or shall I answer this one?
Yeah, I can take it, and you can add on to it. So absolutely. So when I was showing the setup for assignment source and metric source, all we need is one, that Optimizely data exists in the warehouse that you've connected to, and two, that those tables are formatted in a way that it tells us the who saw what when for the assignment source, and then the who did what after seeing that experience. So there's lots of flexibility in what types of assignment sources and metric sources you have, as long as you can tell us those required fields and it has a matching user ID or unique key that we can join to.
Awesome. Thank you, Audrey. All right, next question. I mean, very similar as the one before, but still worth calling out. What if I'm using another vendor for feature flags? Will that work with Warehouse Native? I mean, I can take that one. I mean, that's kind of the beauty of data Warehouse Native. We don't care, or Warehouse Native doesn't care what the assignment source is. Similar to what Audrey just said about Optimizely, right? Is if you already have an existing feature flagging solution, if you already have like Optimizely orchestrating all your marketing tests, but you want to have a single source of truth, you create an assignment source table in your warehouse, you point Warehouse Native against that assignment source, and then you point Warehouse Native against the metrics table that you're interested in, and then the analysis will work, right? So even if you have multiple feature flagging vendors or feature flagging tools within your market present, which we see a lot, by the way, there might be a firm that uses LaunchDarkly, uses us, or uses like Firebase, all in the same organization, because some of these organizations are massive and siloed. This would help them centralize and like help with these tooling sprawl, and at least create a single source of analysis truth. Cool.
Yep.
Next one, I think this is one for you, Audrey, again.
Yeah, I can take this one. So
what if my data is messy and not perfectly structured? Do I need to clean it ahead of time?
Yes. So cleaning is always good. What I like to say is that the Warehouse Native is only as good as the data that you give us. So as I said earlier, at minimum, we need to have the assignment tables, the who saw what when, and the event tables or metric source that who did what afterwards. And if you have that can work. But because the queries run in your warehouse, how efficient they are, or how scoped down they are to the particular experiment you want, depends on you. So it needs to be structured in a way that you can map those columns. Additionally, if you wanted to improve query performance, maybe, or if you wanted to have more custom fields that you could slice and dice by, you would join to other tables. So I would say yes, at least at the minimum, you need to clean it such that the table contains the required fields and It's scoped down to the specific experiment that you want, and it's performant. But what we need from you is not much, which is just those required fields. And I would say that warehouse native is really great for teams that already have dedicated data engineering resources that are managing these data pipelines from different tools. You're putting in your warehouse, maybe they have a staging layer, or they're using an ETL tool like dbt to prep all of these tables before you move on to the experimentation phase, where you're mapping to these and giving us the required fields. So hope that answers the question, and that we can work with it if you have the required fields, but we highly recommend that you clean it and transform it so that it's reusable and performant.
Awesome. Thank you, Audrey. And I think this is the last one, unless someone also wants to write something in the chat. How flexible are assignments and metric sources? Do I need to create one per experiment or one per metric? I guess this is one for you again, Audrey.
Yeah, so they're extremely flexible, and it honestly is up to you. So in the example that I gave, the customer had one general table for everything. So they had one assignment source table, and that would read in impressions and exposures across many different feature flags. So with that general table, they could set it up once, and then when they actually create the experiment, that's when they filter out to the rows that they need. You could also go the route of creating an individual assignment source per experiment, or per experiment, or by team or by category. Maybe we would recommend this if you care about certain teams having permissions only to the tables that they are privy to. Or again, if you want to make the queries more performant, you pre-filter it down to the relevant rows for that experiment. So it's up to you. You can make as many as you want and have many specific scoped sources, or have one general one so that it's reusable and you don't have to maintain it too much, and then filter down later when you create the experiment or the metric.
Yeah, maybe one thing to add to this as well, right? In companies or places where data segregation is really important, right? For example, if you have some folks in Europe and some folks in the States, maybe you don't want the European folks to see the US data, or the American folks to see the European data, right? If you structure your assignment and metric sources and have a data segregation point in view, you can then also use it to control who is allowed to do what kind of analysis and what things for RBAC and access controls within the platform, to really ensure that you have control what the end user from an analysis point of view really sees, which gives you a lot of control and flexibility from just a pure data governance point of view. Cool. All right. That was the last question. If I don't see any other one popping up in the next 20 seconds, I just want to highlight one more thing is please guys, thank you very much, first of all, for coming. If this really was interesting to you and you want to know more about Harness as a whole, we have this little QR code now popping up on your screen, and obviously it was displayed on the slide itself. So please scan it, sign up, and we can have a more structured and more tailored demo for you and your problems that you're facing. And yeah, thank you much for joining. Thank you much for your interest. Also, thank you much again, for Audrey, for giving us this really nice overview of Data Warehouse Native. And if there's no other questions, which I don't think there is, have a wonderful rest of your day. And yeah, see you soon.